Antimatter. It sounds like the stuff of science fiction, like the Star Trek Enterprise using it to fuel their adventures through the universe. However, antimatter is very real and may have real-world applications. Much like Neptune's existence was predicted by mathematics, so was antimatter's. In 1928, British physicist Paul Dirac combined quantum theory and special relativity to describe the behavior of an electron moving at a relativistic speed, which won him the Nobel Prize in 1933. His equation posed a problem. It had two possible solutions, one for an electron with positive energy and one for an electron with negative energy. This led him to propose the idea of antimatter. It wasn't until 1932, however, that Carl Anderson, a young professor at the California Institute of Technology, discovered the first antiparticle, the antielectron or the positron. So what is antimatter? Antimatter is much like normal matter, but it has a reverse charge. These antiparticles can combine to create anti-atoms and anti-molecules, which has been done in laboratories, which will be discussed later. Each particle has an antiparticle, such as the electron having the antielectron, or better known as the positron, the proton having the antiproton, and the neutrino having an antineutrino. However, in the case of the neutrino, which is a neutral charge, the part that is reversed is the spin. An interesting characteristic of antimatter is that when it collides with normal matter, both are annihilated. The result is a conversion of the entire mass, following the E equals mc squared equation, into gamma radiation. And this annihilation of the two causes theoretical problems. Antimatter was created during the Big Bang, along with matter, time, and space. In theory, it was created in equal proportion with matter. So if the universe is equal parts matter and antimatter, how are we still here? Why weren't we annihilated immediately following the Big Bang? Two theories try to explain this. The first, which is my favorite, proposes the possibility of anti-galaxies. Much like cooling a magnet rapidly produces zones of different polarities. After the Big Bang, the universe may have cooled rapidly and produced zones of anti and normal matter. This in theory means that the antimatter may have formed anti-galaxies with anti-stars, anti-planets, and even potentially anti-life. Of course, if such an anti-galaxy collided with a normal galaxy, both would be annihilated. Luckily, we can know that there are none near us. How do we know this? Well, at the fringes of an anti-galaxy, tons of matter would be converted into gamma radiation, which we'd be able to detect. The other theory suggests that there is a slight imbalance between the two types of matter. This theory was supported by Albert Einstein, who stated, "For every 1 billion particles of antimatter, there are 1,000,000,001 particles of matter, and when the mutual annihilation was complete, 1 billionth remained, and that is our present universe." This theory is starting to get a foothold. Experimental evidence has found subtle differences in hydrogen and antihydrogen, along with other antiparticles such as antiprotons and normal protons. This brings us to the research of antimatter. Multiple labs are performing experiments on the subject, but the current leader is the European Organization for Nuclear Research, or CERN. Some estimates put them at 5 years ahead of their competitors. They have a hall dedicated to the study of antimatter and numerous experiments to investigate it. Two of which are the anti-hydrogen trap, or A-trap, which is seen on the left, and the anti-proton decelerators, seen on the right. The first compares hydrogen and anti-hydrogen atoms, while the second decelerates antiprotons to allow further, more in-depth study. They have other experiments that range from studying the biological effects of antimatter and to creating antiprotonic helium to study its differences with normal helium. This research is opening the horizons to potential antimatter uses. The most commonly discussed is rocket propulsion. The theory is to use the energy from the annihilation to fuel the spaceship. The problem is that the production of antimatter is costly, about $100 billion for 1 milligram. To be made commercially, NASA estimates that the price would have to drop by a factor of 10,000. However, this does not stop NASA and other groups from continuing their research, and the Atari group, which is a commercial space program, predicts that the antimatter could be used in about 40 to 60 years. Other applications include weaponization and medical imaging. The energy from 1 kilogram of antimatter can release the same power as its tsar bomb, which is the most powerful nuclear weapon ever detonated. However, the energy needed to create even minuscule amounts of antimatter makes it impractical when compared to the power and ease of modern-day nuclear warheads. On the other end of the spectrum, antimatter could be applied medically. Already, positrons are used in hospitals. PET scans, or positron emission tomography, use the anti-electron particle. By injecting positrons into the brain, a gamma ray flash is released in the collision with normal matter. This flash is different in healthy and infected brains, and the difference can be used to find neurological aberrations. So it turns out antimatter is no longer science fiction. It is real, it can be created, and, in good time, it can be used to further humanity. For more information, you can refer to NASA's site on the status of antimatter and its potential uses, which focuses primarily on the use as rocket fuel. For more on the history and production of antimatter, you can check out Crystal Links, and New Scientist provides a in-depth article on the mysteries of antimatter, such as how we're still here if it was made in equal parts. And on the CERN website, there is an interactive timeline about the history of antimatter and a lot on their experimentation and study. The Institute of Physics provides a lot of information on antimatter-matter annihilation, and Live Science provides information as antimatter as a spaceship fuel. For information on the antimatter being used as a bomb, New Scientist has a great article, and for more on future applications, ZDNet has a great article on the practical uses of antimatter. Thank you.